In general, we won't be able to know the exact value of an irrational root. Sometimes we get lucky, like with the quadratic formula, but usually we don't. We can get as close as we like, though. So the two questions we might ask is, how do we describe how close we want to be? And how do we know when we've gotten there? So in this example, we'll see how we describe how close we want to be. We can say we want an approximation to within 0.01. We know we have a single real zero between 2 and 3. We found that out using the methods that we saw in the last video. Now we want to narrow it down to within 0.01. Okay, so let's strategize for a minute. The fastest way to narrow down the range is to cut it in half at each step. Because if we cut it in half and we cut it in half again and we cut it in half again, it's going to get real small real fast. When do we need to stop? How close do we have to be to know that we've got our estimate to within 0.01? Well, we're going to have some numbers a and b, and we know that the 0 is in between them. If we make our guess the point that's halfway between them, then to know that we're within 0.01 of the 0, we need to have this distance 0.01 and this distance also 0.01. Because then, well, if the 0 is between a and b, its distance from c is less than that 0.01. But then, in order to accomplish that, a and b have to be twice that distance apart. So we keep narrowing until we have points that are twice that distance apart. And then our estimate is halfway between them. Okay, so there's our plan. We're going to use our calculator to help us, and we're also going to use a table to keep track. We start out knowing that our 0 is between 2 and 3. The distance between those is 1, and the point halfway between 2 and 3 is 2.5, which I'll write as 2.5 because we want to deal with decimals here. Now to get started, we need to know where our function is positive and where it's negative. So I'm going to start by taking 2 and storing it in x, and then I'm going to enter my polynomial. X to the 5th plus x minus 42. Because I stored 2 in x, my calculator knows that x is representing 2, so it's going to plug in 2 for x. So my left end, I'm going to have a negative number. And hopefully when I plug in 3, I'm going to have a positive number. So I'm going to plug in 3 for x. And now I don't have to type that polynomial again. I can just scroll up and grab it. And now it plugged in 3 for x, and indeed, that's positive. To find f of my midpoint, I'm going to take 2.5 and store it to x, and then I'm going to go up and grab my polynomial again. So f of my midpoint is 58 and a bit. What I'm going to write in my table is that it's 58 point something. I don't care about the exact number, just that it's positive. So that midpoint is going to be my new right endpoint. Now I know that my 0 is between 2 and 2.5. And those are only 0.5 apart. We're getting closer together. Halfway between those, we might want the calculator again for that. Well, That's going to be 2 plus 2.5 divided by 2. That's 2.25. Store that number in x. Go up and grab my polynomial, and I get 17 point something. Again, I don't care about the exact value, only that it's positive. That's going to become my right endpoint now. So now the distance between these is 0.25, getting closer. And the midpoint? Well, I'll take 2 plus 2.25 divided by 2, and I get 2.125. So I'm going to store that to my x, go up and grab my polynomial again, and I get 3 point something. So now that's my right endpoint. Halfway between those. I'm going to start rounding these at this point, just because I don't want to keep writing that many decimal places. Oh, the distance between these was 0.125. So I'm just going to write 2.063. I want to get my value to 2 decimal places, so if I round these to 3 decimal places, it won't cause me any problems. And just to keep from messing myself up, I'm going to store my rounded value to x. Go up and grab my polynomial. Oh, and I get -2 in a bit. So this gave me a negative value. That's going to replace my left endpoint. So those are 2.125 minus 2.063. Those are 0.062 apart. I'm getting close to that distance I want. And the midpoint of that is 2.094. I'll store that to my x. And I don't want to scroll all the way up and grab my polynomial again, so I'm just going to type it again. I get 0.35 something. That's positive, so that becomes my right endpoint. Those are now 0.031 apart, and the midpoint between them is 2.0785. I'm going to write 2.079. Again, I'm just going to keep that to 3 decimal places. I'm going to store that 2.079 to x, go through my function one more time, and I get -1 in a bit. So that 2.079 is my new left endpoint. 2.094 I keep. The distance between those is 0.015. That's less than 0.02. So now this last midpoint is going to be the point I'm going to use. 2.079 plus 2.094 divided by 2. And I have enough wiggle room to round this. I'm going to say 2.087. And this is where we stop with that last estimate, that last 2.087. That's our guess. 2.087 is within 0.01 of the 0. We might write that as x is 2.087 plus or minus 0.01. Now, normally when we try to give a number to within 0.01, we want it to look like it's rounded to 2 decimal places. And we would need to see, do we want 2.08 or 2.09? Because both of those are between these 2 endpoints. and we don't know which one we want to be actually within 0.01. But, well, if the 0 is between 2.075 and 2.085, those are the numbers we would round to 2.08. If it's between 2.085 and 2.095, those are the numbers we would round to 2.09. And we know that our 0 is more than this, and that it's less than this, based again on the endpoints that we already used. So if we want to know which of these to choose, we just need to see what is f of 2.085. And we can do that on the calculator pretty easily. Just put 2.085 into our x and throw it into that polynomial. And we see that that's negative 0.5 something. So that would be a left end. Our 0 we would estimate as 2.09 if we want to make it look rounded. 2.09 would be the correct rounded number, not 2.08. Though notice that that's actually to within 0.005, so that's closer than we really needed it to be. That's okay. That's still within the margin of error we wanted. It's not necessary though. In reality, just saying what our margin of error is a totally acceptable solution to this problem.